Guys. So start our physics subject GRE. So 79. Which one clearly violate the divergence of B is 0? So basically this means no source. So clearly E, right? Because this point all the things uh, all the points are outward. So this point clearly there's must be a source here. And so basically, divergence 0 means that if you focus in this point, then the flow in should be as the flow out. So you see, in each point, the flow in is as a flow out. On the basically also this, but in this point, all the directions flow out. So D is clearly not okay. And then basically E is the curve is B is 0, but which is not relevant to our discussion. So E say that which of the following electric field could not exist in a finite region. So basically, this is the Gauss law. Tell you that the divergence of E is 0. Divergence of E is 0. So which one has divergence? Z is 0. The first one is partial x over 2xy, so basically 2y, and the partial z minus x, so non-zero. The second is partial, this is j, so partial y is minus x, and the partial z is x. So minus x plus x, this is 0. So the answer is B. And you can check the CD by yourself, which is non-zero. Let me check for you. So C is partial x. So this is z. So the divergence of C is z. And this is x, y, z. So when you do the partial x, you have yz. When you do the partial y, you have xz. So this is xy plus yz. And the E is definitely non-zero. Okay, and 81 complicated, but you can read the question for you by yourself. Basically, you have some time dependence current, and ask you about what? Ask you about the magnetic field generated loop induced by a small loop EMF. Okay, so basically ask you about electromotive force. Okay, so this is easy. That all we need is the Faraday's law. Okay, so Faraday's law, and the Faraday's law comes from the B times A. So basically, your B comes from the circuit, the center of the loop current. So basically, your B comes is just the mu naught I divided by 2R. Okay, so the area is the inner area, basically pi a squared. So the phi is mu naught pi a squared divided by 2R and I, and which I is I naught cosine omega t. Then we just do the derivative. So the cosine derivative is negative sign, and the negative sign will cancel. So there will be plus I naught sine omega t omega. And the R, what's R? What's R? So R is close to B. R is close to B because this current, this loop will give the center the magnetic field. So this R is close to B. So basically, this is the answer. So which one? So what we need to choose is sign, right? So which one is sign? B and C, and which one is correct? The unit. The B is correct. B is correct. So the answer is B. So 82 basically this is somehow like scientific common sense. Ask about atomic gas. A magnetic field differ from the gas absent of magnetic field. Ask about magnetic field. Okay, so the A thing is Stenger. Stenger asks the spin, right? The electron has spin. So it seems 82 82 which we can make a reservation for A. Okay, and the B called Stark effect. Stark effect is you place atom in the electric field, so B is not okay. C is due to primarily nuclear magnetic moment of atoms. So splitting due to the magnetic spin, not a magnetic moment. So B and C are not okay. So basically B and C are not okay. And the A is we reserve. So it may be the answer, but probably not the best one. E said that the number of D said that the number of emission lines observed by a gas in magnetic field is always twice the number. It's not twice, right? Somehow it becomes down 2L plus 1. So not necessarily twice. Okay. Or 2S plus 1. Not generally, not too rigid, right? So E is the number of emission lines observed in the gas magnetic field is either greater or equal to the number observed. Basically, E is 2. It's very general, right? But what 82 said that emission spectrum which of following is true of the phenomenon. Okay, so I think E is better than A because A just said about the spin, right? But E just say that in general it will have some splitting effect. It will have some splitting effect. So I will choose E. Because it focuses on the phenomenon. Okay. Okay, so let's do more. So 83 said that spectral line is produced that is sufficiently dense. That means between atomic collision is much more shorter than the mean lives of atomic states responsible for lines, compared with the same line produced by low and the density gas, the line produced by high density. So ask you about high density versus low density. So if I give you a choose, then the A is impossible, right? You will not choose the same. B said the more highly polarized C, the broader the short shifted toward the blue and spectrum, and E is split to double it. So E is impossible. Basically, splitting to double it means there's a magnetic field. Okay, so the answer should be the border, should be broader, right? Because so if there's more density in a gas, then there will be a lot of energy levels which they have overlap, or you have more various of energy level. So basically you will have a broader spectrum. So the answer is C. And the B, D, E basically somehow impossible. It's no reason that the B will be more highly polarized. And the splitting to double it make no sense, right? So I think it's enough for today, and I will see you guys in the next video, and be sure to subscribe to my channel. Thanks.